In this video, we're going to do some guided exam question practice on the various short questions that have come up from the topic on redox. And pretty much what comes up on the short questions in question 4 about redox is basically the ability to assign oxidation numbers. So before we begin, now might be a good time, if you really need to, if it's a long time since you saw this, to just go ahead and recap yourself, revise the rules for assigning oxidation numbers before we begin. So if you need to pause the video, we'll do that now. Okay, so you're back now. Hopefully you revised the rules, or else you're pretty sure of them already. What we're going to do is we're going to go ahead and work our way through these. So we'll do them one at a time. This first set here was a part D of the 2019 question 4, and you had 2 substances to assign oxidation numbers to. And what they wanted to know is what's the oxidation number of sulfur in these 2 things. So we're going to do them one at a time. We'll do part 1, and the formula for this thing is SO2. So what I'm going to do is I'm going to get you to pause the video and go ahead, write this down, so you can figure out the oxidation number of sulfur. Okay, so you should only be playing if you've done that. Okay, so in this case, what do we know about these 2 things? Well, we know that oxygen is always -2 unless it's bonded to specific things that it's not in this case. So that means oxidation number of -2 for oxygen. In my class, I teach the students to work out the totals for the charges on top. So there are 2 oxygens, so 2 times -2 means we have a total charge of -4 for the oxygens. There's another rule that says that the sum of oxidation numbers, or the totals of oxidation numbers, must add up to 0. So to make this add up to 0, that means the sulfur has to be +4. So +4 minus 4 equals to 0. So there is 1 sulfur, and the sulfur's charges have to be +4. So because there's only 1 of them, that means that this sulfur is +4. So well done if you got that right. Number 2 is find the oxidation number of sulfur in the sulfate ion. So this time it's SO4 2 minus. Okay, so go ahead, pause the video and see can you work this one out. Okay, so you should have assigned oxidation number to oxygen again first, because this is one we know about. And again, oxygen is -2 in this case. So up top, we do the totals. So there are 4 oxygens, so 4 times -2 is -8. Now, this is a complex ion, not a neutral compound. So this one over here was neutral. There's no charge on this, so the charges have to add up to 0. But in this case, this thing has a charge. So the charges up top must add up to the charge on the ion. So because there's a 2- charge on the ion, charges up top must add up to -2. So what can I make the so that the total is -2? So hopefully you worked out that this would have to be +6. +6 minus 8 would leave us with -2. So in this case, the sulfur is +6 oxidation. All right, well done if you got those 2 right. Pretty straightforward. Let's move on to 2017. Again, it was question 4, part B, and it says, write the oxidation number for oxygen in OF2. So we're going to write that down here, OF2. Go ahead, pause the video and see can you work out the oxidation number of oxygen. All right, this is a tricky one. It's one of those ones where there's an exception to a general rule. We know oxygen is normally -2, but in this case, it's with a fluorine. It's with fluoride. It's with fluorine. Fluorine is more electronegative than oxygen, meaning it's going to do the taking of electrons. Fluorine's in group 7, so that means that the fluorine is going to take 1 electron and become -1 oxidation number. Up top, we do the totals, as usual, so that there's 2 fluorines, so total charges on the fluorine is -2. What this means is that the oxygen, because remember the totals, sum has to add up to 0, so the oxygen's got to be +2. So well done if you worked out that the oxidation number on oxygen in this case is +2. If this isn't making sense, then you probably need to go and watch my video on assigning oxidation numbers. Okay, so here is question 2, and it's asking you to find the oxidation number of xenon in XeF4. Go ahead, pause the video and see can you work out the oxidation number of xenon. Okay, so you should only be watching if you've tried this. Again, this time we've got fluorine, the most electronegative atom, sorry. It's always going to take electrons. It's in group 7, so it's going to become -1 oxidation number. Work out the totals up top. There are 4 of these -1s, so that's a total charge of -4. We know that the sum, because this is a neutral compound, must add up to 0, which means that the xenon has to have a charge of +4. +4 minus 4 gives you 0. There's 1 xenon, so that means that that xenon must be +4. Okay, so that there is xenon. So you have that one done as well. Let's move on to the next one. What is the oxidation number of oxygen in H2O2? I'm going to go ahead and write this down, H2O2, and I'm going to pause the video and try this one now. Right, so the eagle-eyed ones of you will know that this thing here is called a peroxide. H2O2 is a peroxide. And there's a special rule for oxygen in a peroxide, okay? We know that the oxygen is going to take the electrons from the hydrogen because the hydrogen is more the oxygen is more electronegative. Now, hydrogen only has one electron to give away. So that means hydrogen has to have an oxidation number only of +1. We work out the totals up top. That means there's a total of +2s for the two hydrogens. We know that the sum has to add up to 0, which means that the oxygen has to have a total charge of -2. So +2 and -2 gives you 0. And what that means is that there are two oxygens and a total charge of -2. So each one of the oxygens must have an oxidation number of -1. So in this case, oxygen has an oxidation number of -1. What I haven't been doing, and I guess I advise you maybe to go back and do this through all of them. I forgot to do it myself, so that's how easily this can happen, is you see what they're asking, sulfur. Maybe a good idea just to clarify with a sentence down the bottom. Sulfur has an oxidation number of +4. Okay, it's probably a good idea just to clarify for yourselves underneath where you've done your rough work what the final answer actually is. Okay, now the examiner will probably look and see, okay, well, I've done that there, but it's going to be nice for the examiner if you've just kind of finished it off, put the answer in a box and said, that's my final answer. All right, so back to this again. Here we've got another substance to do, part 2, and it's find the oxidation number of bromine in KBrO3. All right, so I'm going to get you to pause the video and have a go at this yourself. All right, what rules do we know? Well, we know that oxygen is going to be -2. It's not with a fluorine and it's not in a peroxide. We know that potassium is in group 1 and it can give away only 1 electron. So it has to be +1. So from there, we can do a totals up top. -2 times 3 is -6 total charge. +1 times there's only one of these atoms, give me +1 here. And I know this is a neutral compound, it must add up to 0. So what's in the middle that will make this add up to 0? So again, if you haven't done this, if you haven't got this right so far, maybe pause the video, start again, do what I've done, and figure out what the bromine is. Pause the video, do that now. Okay, so hopefully you figured out that +1, this has to be +5 to give you -6 equals 0. So +1 + 5 -6 equals 0. So bromine in this case have a total charge of +5. There's only one bromine, which means bromine has an oxidation number of +5. Now, I know what some of you may have done. Some of you may have done this wrong. I'll show you what you may have done. You may have done this, KB or O3. And you may have gone, okay, well, oxygen is -2. And then you may have looked at bromine and said, bromine's in group 7, so it must be -1. And then if we look at, okay, let's do our totals. -2 times 3 is -6 up top. -1 times 1 is -1 here. And then this would have to be, okay, so equals to 0. This would have to be +7. And maybe potassium is +7. And maybe that would work. The reason why this is wrong is potassium is in group 1. So it's only got 1 electron to give away. It can end up being +7. It won't want to do that. It's only got 1 electron in the outer shell. It'll give that one up and then it won't give up any other ones. So that's why that would be wrong. So this here, this top one is the only answer that's right here. Okay, let's check. The last one for now is what is the oxidation number of sulfur in Na2S2O3? So let's go ahead and write that down. There is only one part. This is 2002. It was part E of question 4. It was Na2S2O3. Right, so we'll go ahead, get you to pause the video and have a go at this. Okay, you may be confused. I'm going to stop and tell you that this is a really strange one in that, actually no, maybe it's not. Maybe I'm thinking of a different one. I'm going to go ahead and work this out. So oxygen is -2, and that means a total charge for the oxygens of -6 up top here. Sodium is in group 1, which means it's going to be a +1 ion, and there's 2 of them, which gives me a total charge of +2. So what does that mean? This is a neutral compound, so the charges must add up to 0. So what has to be in the middle here for this to balance out? Okay, hopefully you figured out that this has got to be +4, and there are 2 of them, which means that the sulfur has an oxidation number of +2, because total charge of sulfurs is +4, and there are 2 of them, so each one is +2. All right, so then just to clarify, sulfur has an oxidation number of +2. And again, that's really good practice to get into. Examiner's going to love you if you highlight your answer like that and make it jump off the page. Makes it really easy for them to correct, and they'll know that you know your stuff when you do it like that. All right, guys, so that is 5 little examples of assigned oxidation numbers. You can see they come up fairly often, and it comes up in longer questions too, but these are just the ones from the short questions. So very important skill to be able to do. And that's it, guys. We'll see you in the next video.